Out. Greetings and welcome, ladies and gentlemen. We're talking about linear programming, and last night's quest was Prac3.6, Applications of Linear Programming. It's actually from an Algebra 2 book, so not technically from our typical course book. So it says the area of a parking lot is 600 square meters. A car requires 6 square meters, a bus requires 30 square meters. Okay. Whew. Man, the attendant can handle only 60 vehicles. Boy, man, this sounds kind of like parking when I went to the Red Sox game the other night. If a car is charged $250, yeah, we were charged like $40 though, and a bus $750, how many of each should be accepted to maximize income? So to write our variables, oftentimes the variables are found within the question. How many of each? This each is referring to each kind of vehicle. Right? So X should be the number of cars allowed, right, or parked. And Y will be the number of buses. Right? So there we go. All right, so now to write our equations, the E in VISA, although technically these are inequalities. Let's see what facts we've got. It looks like I've got a series of facts regarding square meters, all right, so areas, and then I've got a fact regarding the attendant's capability of processing that many vehicles. The attendance equation appears to be an easier one to write. It says the attendant can handle only 60 vehicles. So in considering between X and Y, what equation could I write?
I tried saving that, and whenever I open the thing up, desktop, it still opens up the Safari, whatever it is.
All right, I'll come by in a little bit and check it out.
I'll get that out as soon as I can.
Yeah. So X plus Y, the number of cars, plus the number of buses should be less than or equal to 60. So that's our first constraint, right? The attendant can't handle more than that, but any number up to it is fine. Up to and including, actually, so that's why it's got the equal part. Now let's see if we can figure out this square meters aspect. Now I know that the parking lot is 600 square meters, so I know whatever my limitations are should be less than or equal to 600. And now what do you think we could do? What about cars in the space they take up? What could we do? So 6 square meters times the number of cars will represent the area taken up by all cars in the lot. Okay. Plus 30y, so the number of square meters taken up by all buses in the lot, if I add those together, that total area has to be less than or equal to 600. I'm assuming somehow this takes into account, space to drive, unless you're literally packing them in, Sunday morning church parking style. Which is a possibility depending on the purpose of this lot. If all of these cars are there for simultaneous events and then all leaving at the same time, sometimes you can get away with that. So let's see. So I agree with that. Let's see. Is it possible to have negative numbers of cars in the lot? No, I assume not. So I would say X has to be greater than or equal to 0, and similarly for the number of buses. I mean, if X was negative, I guess that would be like they are going to rent a car parking space from a neighboring lot and send those cars there, is kind of what that would be. Assuming it cost them the same amount. So that sort of thing could happen. Let's see, and then let's write let's see, is this profit, cost, revenue, maximize income? So that sounds like revenue. So our revenue equation in terms of X and Y is equal to, how much do we earn per car? $2. So 2.5 times X plus 7.5 times Y. And I'm not going to actually solve this for sake of time, but if you want to see a graph, here's what the graph looks like, and there's the solution. So you would have gone through, found all of the intersections of the polygonal convex set, and you would have plugged those into the profit equation and figured out which one was the maximum, right, combination. So let's see. So now I'm going to go and do all of problem 2. At least that's my plan. So it says the cost to run machine 1 for 1 hour. We don't even know what these machines do. That's all right. It's $2. During that hour, machine 1 produces 240 bolts, 100 nuts. The cost to run machine 2 for an hour is $2.40. All right, it's a little bit more expensive. During that hour, machine 2 produces 160 bolts and 160 nuts. With a combined running time of no more than 30 hours. So that's probably related to your labor, the number of professionals you have running these machines that, maybe you only have so many employees and that's the best they can do. How long should each machine run to produce an order of at least 2,080 bolts and 1,520 nuts at the minimum operating cost? Okay, so let's figure out our variables. So let's see. How long should each machine run? Okay, so my variables are not the number of bolts each machine produces. It is the amount of time each machine runs. So X will be, and it looks like it should be hours. Time machine 1 runs, and that would be measured in hours. And Y will be the time machine 2 runs, also measured in hours. And it's important to label your units so that way you can kind of do a little bit of a unit analysis, even if it's just mentally verifying that you've got all of your stuff right. So, and it's difficult to write your equations if you don't know what your units are. Now, I usually like my favorite equation to start with typically is my quantity equation, something where, like in this one, x plus y was less than or equal to 60, right? What is the most I can have my machines run for combined? Yeah, 30 hours. So I'm going to say that the time I run machine 1 plus the time I run machine 2 has to be less than or equal to 30. So I'm wondering, this is probably like within one day, maybe you have 4 employees working 8-hour shifts, and maybe they each have a half-hour break, and that I think would give us 30 hours or something like that. So I'm guessing, I'm just like coming up with an arbitrary story about this 30 hours. Okay, so there's our first equation related to the number of hours available. So let's see. Let's write an equation about the bolts produced. Okay, so this one was, this equation was about hours. I'm going to write an equation about bolts. I'm going to have an equation regarding the nuts, and I think that should do it. And then I'll have my profit equation. And then, oh, actually, wait. I might have, no, we're good. All right, so let's write these equations. All right, so what do I know about machine 1 and its production of bolts? 240 bolts for times every hour that machine 1 can run. All right. How about machine 2? It can make 160 for every hour, right, multiplying by y, that machine 2 can run. Now, what else do I have? What else do I know about the total number of bolts I need to assemble? 2,080 for those of you online. I'll interpret that. I'll have to add subtitles to this video. And how should these relate to 2,080? What sign should I use here? Greater than or equal to. And the words that clued her into that was this phrase right here, at least 2,080 bolts. So that's a greater than or equal to situation. Right? So what's tricky about this is that they blended the way they gave us the information. They gave us the fact for both bolts and nuts on machine 1 all in one sentence. So sometimes you do have to kind of separate those and realize I've got a fact here, I've got a fact here, and I've got a fact here. Right? So sometimes you have to, in order to write your constraint, you might have to pull that information from a few different spots and then pull it all together to write, kind of this guy here. is what we did. So let's do the same thing but for nuts. Machine 1 can produce 100 in an hour, 100 times every hour that machine 1 runs. And machine 2 is 160 times y, so that's the total number of nuts that machine produces in the entire day. We need at least 1,520, right? So I'm going to throw a greater than or equal to sign there. All right, what else do I know about these nuts and bolts? I'm assuming I can't have a negative amount of them. I think that these two equations will already take that into consideration. But I'm just going to throw...
Machine runs, or like, I mean, sorry, how much it costs for machine to run.
Right, so we've got to write, we want a minimum operating cost, so we're actually going to write our cost equation and we're minimizing it, okay? So my P of xy, or actually C of xy, sorry, C of x comma y, writing a capital C next to parentheses always throws me off. Is going to equal, let's see, it was $2 for every x hour and $2.40 for every y hour, so 2.4y, right? I think I got that right. Yep.
Oh,
Yeah. So we're trying to minimize this cost. We want the cost to be as low as possible. So let's talk about solving this now. All right. I think I might do, we could do y equals mx plus b, I suppose, for all of these. So for these three equations, x plus y is less than or equal to 30. I could subtract x from both sides. I'm going to have y is less than or equal to negative x plus 30. There's one. Then I'll have 240x plus 160y greater than or equal to 2080. Man, you guys are going to probably live to be existing in the year 2080. That's going to be crazy. 160y greater than or equal to negative 240x if I subtracted that from both sides. And let's see, then I'm going to want to divide everybody by 160. Is that going to flip my inequality? No. So y is greater than or equal to, let's see, this is going to be negative. The zeros would cancel out. 24 and 16 are both divisible by 8. I think that's negative 3/2 x. And 2080, what does that divide by 160? 13. Okay, so there's another equation for us to graph. And let's see, then I've got hundo x plus 160y is greater than or equal to 1520. So 160y, wait, did both of those? Okay, both of them produced. I didn't mix up my 160s there, did I? Okay, all right. I just wanted to make sure I threw those in the right spots. I did. Okay. Whew, I was worried. Is greater than or equal to negative 100x plus 1520. Then I divide. I wouldn't have to flip the inequality because I'm dividing by a positive. And let's see, this will be negative 10 over 16. Both of those are divisible by 2, so that's negative 5/8 x, I believe. And 1520 divided by 160 is going to be plus 9.5. Yep. And actually, I allow decimals specifically in the case of y-intercepts. Usually one of the only times I allow them. So here's all my equations. I technically also have this vertical line, this horizontal line, but I have a feeling that these two greater than or equals are going to be more constraining than those ones anyway. Let's see. So I'm gonna graph this using my little awesome thing. Let's see, grid form, square grid. Let's see. This exists primarily in the first quadrant. let's see, this one goes as high as 30 in both directions. This one's as high as 13, this one's as high as 9.5. So I think if I scroll out to 30 in both directions, I should be good enough, like so. Let's see, let's graph negative x plus 30. So to graph this by hand, I would go up to 30 on the y-axis and do down 1 over 1, and this is what I would get, right? Let's see, then I'll graph this function, negative 1.5x or negative 3/2 x plus 13. So I'd go up to 13, and then I'd plot that point and go down 3 over 2, down 3 over 2, right? And I'd keep doing that. Oh, it looks like we might need those x equal to ones. Then I'll have this guy here. Let's see, can I fit them all? Graph. So this will be negative 5/8 times x plus 9.5. So I'd go up to 9.5. That would be a little bit tricky, going down 5 and then over 8. Plot that point, and I would have that. And then I do technically also have y equals 0 being my y-axis, and then I technically also have, let's see if I can just do this, construct a, no, that doesn't count as a point, does it? Let's see, let me hide these guys, and then I'll make my own point. Make my point, here we go. And let's see, and then select this line, and I'll construct, no, it's still not liking me. Why isn't it liking me? That one, construct. No, it's not letting me do that, but that's fine. I am going to throw my points here. So let's see, there, there. This intersection right here between these two actually would have been a little bit tricky to get. That you probably would have had to do a system of equations to find. But it looks like I'm going to end up having a pentagonal shape, irregular pentagon, of course. This does not appear to have equal angles and everything. And it looks like that is what we would have. All right. And it looks like my answer matches that one in the packet as well. So let's see. Paste. Bam. And I'm running out of room down here at the bottom. No. All right. There we go. So let's label these points. I guess this could be A. This could be B. It doesn't matter how you label them. C, D, and E. So let's see if we can find these. So point A is, let's see, that one was the one at 0, 13. Point B is the one that is at 0, 30. All of these, by the way, were solid lines making up these boundaries. And, right, it was shaded above these guys, below this guy, to the right of this guy, and above that guy. So that's how I got my shaded region. I think you guys were pretty good on that, so that's why I'm focused just on the linear programming aspect of this question. Point C is 30, 0. So that would be the same situation. What was our x representing in this problem? X was the number of hours machine 1 runs. So 30, 0 would be a situation in which you don't even run machine 2. You only run machine 1, would be that situation right there. Point D, that one's a little bit harder to find. Let's see, that is something, 0. Point D is made up of the equation, this equation here. So if y is equal to 0, I'd have to take 9.5 and multiply by 8 and then divide by 5. I think this crosses at 15.2, if I'm not mistaken. I believe. And then point E, let's see, wait a minute. Did I hit A yet? Yeah, okay. Yep. and point E is the intersection of these two lines. So tell me, how could I find the coordinates of point E? This is, so are you trying to read this off the graph? 1, 2, 3, 4. And does that happen to land exactly at 7? I'm not sure, because some of this one's points landed on decimals for sure. Well, how could I find it exactly? Plug what in? I'm still not entirely sure that that lands on 4. It looks like it's likely. It is on 4, you're that confident? But if you were doing this by yourself and you didn't have this graph, how could we find the intersection between these two lines? Elimination method, substitution method, Kramer's rule, matrices, any of those. In fact, you don't even have to use those versions of the equations. We could have used these two versions if we wanted. And in this case, I would definitely eliminate the y's, right? Actually, you know what? Let's do that. If you're not interested in this portion of the video, feel free to fast forward a few moments and you'll be good. Let's see. So this is all for the sake of finding point E. So here's my point E work. And this would all be something that could get you partial credit on a quiz or a test. So let's see. I'm going to multiply equation 2 by -1 in order to get my opposite y's. So I'll have -100x minus 160y. Technically, I don't even care about the inequalities at this point because I want the intersection, so I'm just interested in the equal to aspect. And -1520. Subtract them, I'll get 140x. The y's cancel out, equals, let's see, 2080 minus 1520 is 560. Let's see, is that going to fit in 4 times? We'll find out. Divide by 140. It might, actually. What's 56 divided by 14? 4. Okay, so it was exactly 4. Now I am confident. And let's see, in order to find the corresponding y coordinate, I could then take this and plug it into, I don't know, I'll plug it into this equation's x. So I'll have 100 times 4. You also could have used matrices or anything like that. So let's see, I'll have 160y equals, subtract 400 from both sides, that's 1120. Divide by 160, 1120 divided by 160, I get 7. Aha, so it did actually land perfectly on the grid. But I had no confidence in that possibly being the case the way that it was showing. So this is, with all of my work, I've justified that it is 4, 7. Now what do I do with all these points? Plug them in to our cost equation. So 2x, 2.4y, right? So 2 times 0 plus 2.4 times 13. I'd do 2 times 0 plus 2.4 times 30. I would do 2 times 30 plus 2.4 times 0. Let's see, that one's going to be 60 right off the bat, I know that. We could do 2 times 15, that's not a 15.2, plus 2.4 times 0. And we could do 2 times 4 plus 2.4 times 7. So let's see, 2.4 times 13, I get 31.2. That one's less than 60. 2.4 times 30, that one's going to be more, so I already know that's not going to be the answer. That's 72. 2 times 15.2, 30.4. Ooh, we've got a new lead. 2 times 4 is 8. 2.4 times 7 plus 8. Oh, and E happens to be the solution, right? So 24.8 is my minimum cost. So the answer that I would say, this is answer, not like A, would be run machine 1 for 4 hours. Machine 2 for 7 hours. And you minimize cost. Is that the right answer? Woo! We got it. Well, that was a long problem. I realized that was a long time to go over homework, but these problems are long, and that's why I only gave you 2 of them last night. How kind of me. I must be some sort of benevolent mathematician. Well, anyways, internet friends, thanks for watching. Bye-bye.